Hello, good evening, students. Welcome back to my channel. This channel for KSET and CSIR, UGC, NET, IIT, JUM students. So, friends, students, today I am starting in the linear algebra subspace. Already, I upload the video about vector space and MCQ of the vector space. Minimum 20 MCQ I already solved. So today I start a subspace with so many examples and I solve 15 MCQ, near 50 MCQ about subspace only for related both KSET and CSIR UGC NET. So now can I start? So subspace here, observe here. So what is subspace? We know that subspace is a subset of a vector space. Suppose you consider W is a subset of a vector space, V is called a subspace if it is itself vector space under the same operation. Same operation means which is satisfying the vector space, that is the same operation means vector addition and scalar multiplication, zero vector. These both are satisfied, that set is called or that subset is called a subspace. Three important condition is there. That one, see, important condition is there. Subset W subset V is a subspace if closed under addition. If U comma V belongs to W, U plus V also belongs to W. Closed under scalar multiplication. If U belongs to subset, C belongs to field, C into U belongs to W only. So contains zero vector, 0 belongs to W. If this satisfies, W is a subspace. And also small, and another one, only one condition means short tricks is there for find out in subspace. If for all U comma V belongs to subset and scalar A comma B, so AU plus BU belongs to W, belongs to subset, that is also called W is a subspace. No need to check that is contains zero vector or closed under addition or closed under scalar multiplication. No need to check that three conditions. Only want to check AU plus BU BV equal belongs to W or not. That only you satisfy that subset is called a subspace. And so ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ which one is a subspace, that is already vector space, satisfy the same operations also. So we see the example. So now see the properties. After that we can take example for the subspace. So what are the important properties of the subspace? Properties are must and should important for KSET and CSIR UGC NET exam. Every vector space at least two subspace. At least every vector space has at least two subspace. Zero is a trivial space and whole space. V is a whole space and zero is the trivial subspace. Intersection of subspace always a subspace. Intersection of subspace always a subspace. Union of subspace not necessary a subspace. Solution set of homogeneous system Ax equal to 0 is subspace. Solution set of homogeneous system, homogeneous Ax equal to 0, subspace. Solution set of non-homogeneous Ax equal to B, not a subset. This is the 5 important properties of subspace. What is the first one? Every vector has at least two subspace, at least, not at most, at least two subspace. 0 and V. 0 means the trivial subspace, V means whole space. Intersection of subspace is always subspace. Homogeneous system Ax equal to 0 is always subspace, but union not necessary. Solution of non-homogeneous Ax equal to B, not a subspace. This is the most important property of the subspace. So let's take example for subspace. First example, what is the example? W equal to x comma y belongs to R square such that x plus y equal to 0. R square such that x plus y equal to 0. Observe the condition first. X plus y is equal to 0. So here subspace, we know that three important condition is there. First one is zero vector, and second one is closed under addition, and third one is closed under scalar multiplication. Want to check three conditions also, otherwise one short trick is there, we want to use that one also. So first I will check if it is satisfied the zero vector or not. First one satisfy. Consider 0 comma 0. So what is the condition is there? X plus y equal to 0 means 0 plus 0 what? You take 0 plus 0 equal to 0. So first one is satisfied. So as it is, check the second one, closed under vector addition. Closed under addition. How to check the addition? First consider two vectors x1 comma y1 and x2 comma y2. x2 comma y2 both are belongs to set W. After that, what is the condition is there? What is the condition is there? Suppose you take u plus v. This is the u and this is the v. So take u plus v. First one 0 vector. Suppose you consider 0 comma 0 vector belongs to set W, then satisfies the condition. What is the condition is there? X plus y is equal to 0. This is the main condition. So 0 plus 0 equal to 0. This is satisfy first one. And what is the second one condition? Suppose you consider u equal to x1 comma y1 and v equal to x2 comma y2. This both are belongs to W, and suppose add this both, we got x1 plus y1 plus x2 plus y2. We know that what is the word x1 comma y1 is nothing but equal to 0. x2 comma y2 is nothing but equal to 0. So here 0 plus 0 what? 0. So closed under addition also is satisfied. So second one also satisfied, first one also satisfied. What about the third one? So scalar and closed under scalar multiplication. Suppose x1 comma y1 belongs to W, that is equal to 0, and C belongs to field F. Implies scalar multiplication is C into x1 comma y1. So C into x1 comma y1 means C x1 comma C y1. So what about this value? Nothing but C into 0. C into 0 what? 0. So this is three condition also satisfy that condition x plus y equal to 0. Therefore given set is best example for subspace when giving the R cube subspace. Okay, understand this one. This is the first example. Next go to the second example. Observe the second example, W equal to x comma y such that x plus 1 equal to 1. Observe the condition, and this W belongs to R square. W belongs to R square. We already checked the first example, R square is subspace. But and that condition is changed. Condition is x plus y equal to 0. Here x plus y equal to 1. In the subspace, first want to check the 0 vector. Suppose you consider 0 comma 0 belongs to W. Then check the condition x plus y equal to 1. 0 plus 0 equal to what? 0. But 0 not equal to 1. So this is not a subspace. This is not a subspace. No need to check the other two conditions. No need to check the other two condition. One is not satisfied, so it is not a subspace. This is the example for subspace. Next, have to go to solve the MCQ. Previous year repeated KSET and NET questions. So let's start MCQ with solutions. So let's begin MCQ with solution now. First MCQ, let W equal to x comma y comma z belongs to R cube, x plus y plus z equal to 0, then W is. So first observe the condition x plus y plus z equal to 0. Option A, not closed under addition, not a subspace. A, subspace, not closed under scalar multiplication. This MCQ option is C, subspace. Exactly this satisfies the subspace, because when giving the x plus y plus z equal to 0 condition, this satisfy both this equation satisfies 0 vector. 0 vector, suppose you consider 0 comma 0 comma 0, this satisfies 0 plus 0 plus 0 equal to 0. 0 vector is satisfied. What about closed under addition? Suppose you consider u. What about x1 comma y1 comma z1? V. x2 comma y2 comma z2. Suppose you both consider both are equal to 0. 0 plus 0 equal to 0, and scalar multiplication c into x1 x comma y comma z is nothing but c into 0 means 0. This satisfies 3 condition also. That's why option C is the correct one. This equation is subspace. Okay, understood students? When you solve the MCQ, please revise the definitions and properties and what is the condition for this, what is the condition is given, what we want to apply. Please carefully observe the each and every options. Okay, next second one MCQ. Second MCQ, which of the following is not a subspace of R square? First observe the first one. Here x comma y is to x equal to y. So this one is this equation, line passing through the origin. So when line passing through the origin, that set is satisfy the all condition of the subspace. So this is the subspace. And what about option B, x comma y equal to x plus 2y equal to 0? This second one is linear equation, homogeneous linear equation, that is also a passing through the origin. This is also passing through the origin, that is also a subspace. And option C, x comma y x y equal to 0. This is not a subspace. I will explain, just wait. And see the option D, x comma y equal to x equal to 0 means this is y axis. This is y axis means this is also passing through the origin. This is also passing through the origin. So this is not a, this is also a satisfy the subspace. So what about option C? Here observe x comma y equal to x into y equal to 0 means this option C is passing through x axis and y axis both. When this passing through x axis and y axis both, this not satisfy the closure under addition. Why not satisfy the closure under addition means? Why not satisfy the closure under addition means, suppose you take u equal to 1 comma 0 and v equal to 0 comma 1. So multiply this, we got 1 into 0, 0, and 0 into 1, 0. Suppose add this both, u plus v, 1 plus 1 equal to 2. 2 is not equal to 0. So this is not satisfy the closure under addition. That's why option C is not a subspace of R square. So next MCQ, third question number 3. Solution of set Ax equal to 0 is always A empty, B not a vector space, C a subspace, D a singleton. Ax equal to 0 is null space or kernel. So check this is subspace or not means satisfy the 3 conditions. First one is 0 vector. Suppose you consider A of 0 equal to A into 0 what? 0. Satisfy the first condition. What about closure under addition? Suppose you take Ax equal to 0 and Ay equal to 0. Add this both, A into x plus y. A into x plus y means 0 plus 0. 0 plus 0 is always 0. So that is also satisfy the means A into, and last condition is closure under scalar multiplication. Suppose you consider one field C belongs to F and Ax equal to 0, that also belongs to set. Suppose C into Ax means C into 0. C into 0 what? 0 only. So this one, what is null space? Null space or kernel satisfy the condition of the subspace. That why C is the correct option. The solution set of Ax equal to 0 is always a subspace. Okay, next fourth MCQ. Union of two subspaces is always a subspace, never subspace. Subspace only if one is contained in other. Always a vector space. So we already study the properties of the subspace. According to subspace, union of the two subspaces not necessarily subspace. What is the condition? Not necessarily subspace. So what is the correct option? Not necessarily subspace, but option C is not always subspace, not never subspace, subspace only if one is contained is other. What is that meaning? Suppose take two subspace is there, W1 and W2. Suppose these both are union of W1 union W2 is a subspace. When is subspace, W1 is subset of W2. Otherwise W2 is subset of W1. Only that time both are union of two subspaces subspace. Okay. Next MCQ. This MCQ asking in CSIR UGC NET 2012. Let W equal to x, y, z belongs to RQ, x plus 2y plus 3z equal to 0, x minus y plus kz equal to 0, for which value of k, W is a subspace of dimension 1, k equal to 1, k equal to minus 1, k equal to 2, k equal to 3. So W is a subspace of dimension 1. So here R cube is there. When R cube is there, what is the dimension? Dimension is 3. But here, so dimension, when R cube is there, dimension is 3. Dimension is 3. So why giving, so W is a subspace of dimension 1? Because here linear independence is there. Linear independent continuous is there, 2 is there, 3 minus 2, 1. So when this happen, when k, how much k value is? K value 1 minus 1, 2 or 3. Want to find out that, check. For this problem we have a two method for solving. First one is rank nullity theorem, other one is direct method. I can use direct method because here dimension of the W is given 1, but here R cube is there. We know that dimension of the real value is 3. So using rank nullity theorem, 3 minus 1 is how much? 2. 3 minus 1 equal to 2. So what about the rank of W? Rank of W equal to 2. So here observe this. What is the x value and x value? 1 by 1. 1 by, what is the x value? 1 by 1. Next 2 by minus 1 equal to k by 3. And observe here this 3 is not equal. Both are not equal. That's why k equal to 3. What is the option is correct? Option D is correct. This is the short tricks for find outing the k value. So sixth question, this question asking in CSIR NET 2020. Let W1, W2 belongs subset of R cube be subspace with the dimension 1 equal to 2, dimension W2 equal to 2. Then possible find the value dimension W1 intersection W2 is. Find out the dimension W1 intersection W2 using the formula. Want to find out that. So what is the formula? So here no space is there. So write dimension in D form. Dimensional V equal to dimensional W1 plus dimensional W2 minus dimensional W1 intersection W2. Okay, I will put only intersection symbol because no space. So what is the dimension of V? V is nothing but vector space. Which one is R cube? R cube means what is the dimension of R cube? 3 is 3. And equal to what is the dimension of W1? 2. What is the dimension of W2? 2. And what is dimensional intersection? Want to find out, write D only. So here 3 equal to 2 plus 2, 4 minus D. So here, so 3 minus 4. So observe here, 3 minus 4 equal to minus D means minus 1 equal to minus D. So minus minus get cancel. What is the D value? 1. So D is 1 only. So observe the option clearly. A 0 only, B 1 only, C 2 only, D 1 or 2 only. So when we got the option, we directly put B. But B is not correct. Why B is not correct? Because here given dimension of W1 equal to 2 and dimension of W2 equal to 2. When we adding both dimension W1 plus W2, it become 4. But what is the dimension of the given set? Set is RQ. What is the given set? 3. So 3 is the set. So not more than 2. Dimension of the W1 intersection W2 not more than 2. That's why we want to put both the value D equal to 2 or D equal to 1. Both is possible. That's why option D is the correct one. Option D is correct one. Dimension of W1 intersection W2 is 1 or 2. Okay, understood? This is very tricky question. So please observe the question and observe the formula. After that, go and solve this problem. Okay. So observe the seventh question. This question asking in KSET 2021, which of the following set is not a subspace? So first observe the first option, x plus y equal to 0. So in the subspace, you want to check the three conditions also: 0 vector, closure under addition, and closure under scalar multiplication. But here x plus y equal to 0 is become x equal to minus y means what? The line pass through the origin. Which line pass through the origin, that is always satisfy the axioms or conditions for the subspace. So this is the subspace. And what about x equal to 0? X equal to 0 in the y axis, that is also line passing through the origin only. So this is also subspace. X comma y, x into y equal to 0. This is not satisfy the closure under addition. Closure under addition not satisfied. That's why this is not a subspace. Y equal to 2x also line passing through the origin. Y minus 2x equal to 0. Y minus 2x equal to 0 line through the passing through the origin. That is the option C is not a subspace. So understood. So can I go next MCQ? So let's see the 8th question. CSIR NET 2019. This question asking in CSIR UGC NET 2019. Let W subset of Rn satisfy U comma V belongs to W and U minus V belongs to W. Then W is always subspace. Subspace only if contains 0, not subspace vector space. So if you understand the subspace topic, please answer this question. DM this answer. DM this question answer. I will check. I will reply for your comment. Thank you for watching. So I love you student. Thank you for watching. And once again I will tell, I already put my vector space explanation video and MCQ and paper 1 teaching aptitude, each and every topic explanation with MCQ detail in Kannada and both Kannada and English language in the general paper, not in a mathematics. Mathematics I will only explain in the English language. So please go and watch all the videos if you want to become a assistant professor or lecturer for a degree college or something. So please watch my video. If you want like my video, please like my video and comment karo please if you like my video. Thank you for watching. Love you students.